arc suppression. Okay, now diodes for directional control. A little different. Okay. And the key here is to understand that I don't really care which direction current flows, because on the schematic I don't care. Okay, so what I would do is, if I have a schematic, right, so here's a schematic, and let's just draw it as a ladder diagram. So we'll put positive here and we'll put negative here, and we'll put a fuse, and then we'll put a switch, and then we'll put a diode just for the heck of it, and then we'll put a coil. There's another symbol for a coil, and then we'll put another diode in here in reverse bias because that's for suppression. The point is that these are the same diode. They're the same part number 0001, and this is going to be part number 0001. Okay, so they're the same part number. Okay, and there's no such thing as a positive diode or a negative diode. There is a positively constructed diode. So when you have the diodes in the alternators, if any of you guys are doing the alternator the alternator rebuilding, some of you do alternator rebuilding, some of you don't. Just depends on what you're doing. Okay, and they'll have a little diode symbol on the side, maybe, maybe not. Okay, this is a positively constructed, negative. This is a negatively constructed diode because the little lead here is negative. Okay, because that's how they do it. But the diode inside, whatever's inside here, the diode stuff that's inside here, the diode stuff inside there is the same stuff that's in the positive diode or the negative. And quite frankly, I don't know. I mean, you figure it out. If you're doing this, you figure it out, because use your diode check function and measure what are called positive diodes and negative diodes, and figure out which way it is, all right? Because either the negative lead is here, which makes it negative, or the base is negative, which makes it negative. I don't know. Flat out, I don't know. But what I do know is that the diode junk in here is the same as it is in both of them. It's just flipped over. Okay, so a positive diode is a negative diode with the guts flipped. That's it. Okay, so, and a lot of people want to believe that all this stuff is different, but it's not. Okay, so in this case, this diode, of course, is going to be for arc suppression to save this. This diode here would be for directional control in case we had other things connected in and blah, 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 blah. Okay, so let me draw a couple of circuits for directional control, for an illustration of directional control, and see if this makes sense. Okay, so there's a switch. All right, and then let's say that that's going to turn on a motor, just for the heck of it. It's going to turn on a motor. Okay, we'll call this switch 2. We'll call this switch 1, simply because that's how the schematic would look. We'll call this line 1. We'll call this line 2. And we'll call this line 3, because that's how it works. That's how these schematics work. And we'll call this line 4. All right, now, let's say that we have another circuit that has a switch, and let's say that it has a, well, I'm making this up on the fly, so I could screw it up, but that's, if I do, I'll fix it. We'll call that switch 3, and let's say that that turns on a second motor, and let's call this motor 1, M1 and M2, and then let's turn on another switch which turns on a solenoid, and we'll use this symbol for the solenoid this time, and we'll call that SOL1, and there would be a diode across it, probably like this. Okay, and what you might say, okay, switch 4, I guess. Okay. Well, let's say that we want this solenoid to turn on anytime the motor turns on. Okay, so if we close switch 2, we want the motor and the solenoid to turn on. Okay, and we want the same thing to happen here. Or we just want the solenoid to be able to turn on by itself. Okay, so how would we do this? Well, we're going to use diodes, and I'm thinking furiously in my head because I don't want to screw this up. So it's fairly straightforward. Let's just say that we're going to connect, and I'll use a little bump, even though a lot of times you won't see that anymore. Okay, so now what's happening is this switch will turn on this solenoid, but it will also turn on this motor. So actually it's going this way, right? So this switch will turn on the solenoid. Okay, but we also need the same thing here so that when this switch turns on, okay. All right, so now we got a problem though, because everything's turning everything on. Because even no matter what you turn on, everything turns on. So this switch would turn on this motor, this switch would turn on this motor, this switch would turn on, this switch turns on that solenoid, turns on that motor, turns on that motor. Okay, so no good, we can't do that. Okay, so the first thing we do, since we don't really want anything to go backwards, and I hate using that phrase backwards because I don't really care about direction. But because diodes do technically have a direction, it's the only time I think the word backwards makes sense. So let me see if I do this right. Let me make this work. We can put diodes anywhere we want. So this is going to turn on the solenoid, and we want it to also turn on the motor. So what we would do is we wouldn't work here, we'd work here and here. So in order for switch 1 to turn on this motor and the solenoid, then there's going to have to be a diode here to not let anything from here come back up there, because we want this switch to turn on that motor and to turn on that solenoid, but not turn on anything else. So we would do the same thing here, I think. If I'm wrong, feel free to redraw it and email me. Okay, so now this switch will not turn on the motors. Okay. Yeah, that's right. This switch will turn on the solenoid, but it will not turn on that motor, and it will not turn on that motor. But switch 2 will turn on motor 1 and the solenoid, but it cannot turn on blocking, off, reverse bias. Switch 3 will turn on that motor, but it will, motor 2, but it will not turn. Switch 3 will turn on this motor, motor 2, obviously. And it will also turn on the coil, but it will not turn on motor 1. And if we switch on the solenoid by itself, then the solenoid just turns on. Okay? So these are being used for direction, and this is being used for suppression. Now we can make this even more interesting by having another component down here and have a light, for example. And I'll use this symbol for a light because you need to learn that one too. Okay, now anytime the solenoid comes on, this light turns on, right? Okay, so anytime the motor is on, then that motor will also cause that light to turn on. Same here. So that'll tell us that but if we don't want that to happen, if we only want the light to warn us that the motor's, then we put a diode here. Okay, so now what changes is that this light will not turn on unless that switch is on. So this tells us that the solenoid is on. Oops. And just to make this a little bit more legitimate, if it's a panel light, okay, all right, there we go. Okay, so here's a light, and because I'm using this, what is technically a DIN symbol, DIN. If they do it right, then that double line means it's in a panel. So it's actually kind of cool because it's a really good symbol. I like it. So these are directional diodes, and this is a suppression diode. And that's a suppression diode, and that's that. So when you build the system, the diodes are going to be put in either up or down or left or right, or I mean the diodes could point this way or that way or up or down or in or out. And the way I explain it is you don't go to the hardware store and buy north-facing nails and south-facing nails and east and west-facing nails. You just buy nails, all right? And nails can go in any wall, up or down, in or out. Diodes are the same thing, okay? They work exactly the same way. Okay, so for directional control, the key is that when you redraw the circuit, the question becomes, and I'll redraw this one first because it's my quick and dirty. So it's that. Remember, that's 50% correct. I'm going to put the solenoid in. It's pretty close to the ground, so I'll just put the solenoid in. And then I have a switch up here. And then I have a diode pointing in this direction, which matters. But it doesn't go anywhere else, so I'm reading this way. So current, I wouldn't go up this way and looking for positive because I'd be blocked. And I wouldn't go up this way looking for positive because I'd be blocked because the arrow is going against me. Okay. So, did I say that right? Yeah, no, that's right. I'm sorry, I said that wrong. Okay, this one goes up and it can be turned on, and this one can also be turned on. But if we're only drawing circuit 4, then this diode is going to protect the light, and what I would do is I would draw another quick and dirty, and I'd put a ground, and I'd put the light, and then I need voltage for the light, but it comes off of this switch 4 here, so I'll just draw that. Okay, and that's pretty much it, right? Now, of course, there are other circuits that can turn the solenoid on, other switches, but this is the basic quick and dirty drawing. So this light will turn on when this switch is closed, and then this solenoid turns on when that switch is closed. But it also has other diodes coming in from other locations, and I would draw them that way. And this is going to come from switch 3, and this is going to come from switch 2, and this is switch 4. Okay, now this is my redrawn schematic. I don't really care about this stuff up here, but what it's telling me is the solenoid and this light, call it light 1. This light will work when we turn on switch 4, but it will only work when we turn on switch 4 because this diode here, this diode is blocking voltage from any other circuit to come down here. All right, now we could put a light here, for example. You could put a light here. Let me think if I'm doing this right. Okay, I can put a light here. See if that's right. You guys tell me if I'm right here. Switch 3 will turn the light on, but switch 2 cannot, and switch, there's a bug in my light and it's just making noises. Okay, yeah, that's right, that's right. So I could put another light here, if I'm not mistaken. Here, here's another symbol for a light. I'll do that. So I'm thinking, what if I did this right, then that switch turns on that motor and that light. It also turns on that solenoid, but it does not turn on that light, and it does not turn on anything here. If I close switch 3, it turns on motor 2, and it turns on this light, and it will also turn on the solenoid, but the solenoid light doesn't turn on, but it can't come back up here. And if I turn on switch 4, then switch 4 is going to turn on this light and the solenoid, but it won't turn on anything else. Okay, so all that really matters is it pointing towards ground? or is it pointing towards positive? And that's really all that matters, okay? So the reason I'm going to this trouble is because what I don't want you to do is think, oh, well, you know, positive flow, negative flow, blah, 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 blah. Okay, please don't do that. Please, 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 please don't do that. Because that just kind of makes things kind of crazy. So, quick reminder that I treat a suppressed solenoid or relay or whatever, clutch, whatever, I treat this as one thing, okay? And that makes it simpler because you don't have to worry about current flow. When I'm looking at diodes in circuits, what matters to me is the diode pointing towards ground or is it pointing towards positive when the circuit's turned on. So switch 4, everything on this wire becomes positive. So the negative side of the diode is touching positive, so the diode's off. And here the negative side of the diode's touching positive, so the diode's off. Okay, well if I close switch 3, then switch 3 is going to turn on the motor and the light, but it also is touching the positive side of this diode, and the negative side of the diode is touching ground, so this diode would be turned on or in forward bias. So the bias, this is important, the bias flip-flops. Okay, so the bias of the diode flip-flops. Depending upon, and we go back to the first, depending upon the voltage, or if you want to get persnickety, we could call it the polarity, right? Okay, so that's how diodes work for arc suppression, and that's how diodes work for directional control. They do have amperage ratings. So a diode will have, put it right here, you'll have an amperage rating, and you'll have a voltage rating, and you'll have some other ratings, and bigger is more, and electricity, as we've always said, the bigger something is, the more heat it can handle. And heat is a function of both of those, because that makes watts. All right? So volts and amps make watts. Watts equals amps times volts, which is wave. And volts and ohms make amps. Watt's law. Watt's law. Watt. And this is Ohm's law. Okay, so there's that and there's that. Just throw it in there. So the polarity of the voltage is what's going to determine whether or not the diode is on or off, and it's technically a switch. In addition to being a check valve, it's also a switch. So that's pretty much it. And now what I'll do is I'll do the card. I'll do the card that we have, and it's already built, so really it's going to be kind of anticlimactic because I'm just going to show you how it works, and after all this you ought to be able to figure it out yourself. So whichever video is next, which I think will be C, 10C, run onto that, and hopefully this helped. So we'll see you guys later. Later.